Just now we studied that I times j or j times I is 0, but I square is 1, right? We apply that concept and see what happens. I square is 1, so we have xm, all right? And ij is 0, right? The angle between them is 90. So that is gone. Ji is also 0, that is gone. So we have xm plus yn and j square is 1. So what we are saying is multiplying a dot b using the column vector style x, y, mn, if I write like that, x, y and mn, those are the numbers please. To find the dot product we simply say xm and plus yn. Alright, that's what it means. That's why we multiplied those vectors like that. 3 4 is 12, 4 6 is minus 24. Right, that's the, with this I think some of the basics are finished. Question number 1. We have two vectors a and b, 5i, 2j, 3k, that's a 2i, 1j, nothing means 1, and minus 2k. They wanted us to find the a dot b, which is the dot product, right? Remember, it's easier to find the dot product using the column vectors. That's much easier to do. So let's write two columns there and write these ijk numbers, 5 and a 2 and a 3. This is a 2, minus 1 and minus 2 please. 5 times 2, 10, minus 2 times 1 and minus 3 times 2, 6. So we have a 2, right? That is the answer for the a dot b, that's all. And the second part they asked us is to find the modulus of a. Modulus, remember, you know, it's the Pythagoras. So I'm taking the first one, which is 5, 2, 3. So it's 5 square plus 2 square plus 3 square and under the root. That's the modulus of a, and the answer for that comes down to 25. That's a 4 and 9. 25 plus 4 plus 9, 13. Under the root we have a 38, isn't it? 25, 4, 9. Yeah. So 5, 3, 8 and 2 plus 1, 3. So it's a 38 under the root. So we leave it like that. Then we look at the modulus of b. They wanted us to find modulus of b as well. It's a simple Pythagoras, please. You all know how to do that. So it's 2 square and plus minus 1 square. Doesn't matter. We get the plus value anyway. Whole square under the root. That's a 4 plus 1 plus 4, which is a 9. That's a good looking one, which is 3. So we take those two values. That's modulus of a, modulus of b. Then part 3, or question 3, they said, find the angle between the two vectors a and b. They are vectors, please, right? The formula we know, cos theta is equals to, cos theta equals to a dot b, the dot product value divided by modulus of a times modulus of b. That's what we have. If we get a minus value, the angle should be the obtuse. If we get plus value, it should be acute angle, please. So we'll be taking a dot b, which we have already found. A dot b is 2, and that 2 comes there. Sorry. 2 is on top, and the bottom one is root, say modulus a, modulus b, which is 38 and 3. So that's a root 38 and a 3 times. Let's check this again, please. That's a 25 plus this is 4 plus that's a 9. 9 plus 4, 13. 2, 1, 3. Yeah, correct. So now we simply use the calculator to find the answer. Second function cos, you can do that please. Second function cos fraction, get the answer please, and denominator is root 38, moves away and times 3 and close bracket. That's what we have, and that should be now equals to, it's an acute angle 83.8. to three significant figures. Right, 83.8 degrees. That's the angle between the two vectors, okay, that we have. That's how you find the angle between two vectors. There is an angle between two lines that we will do later. Firstly, now we are trying to do the sums that we have learned from the basics, right? So let's go ahead and do few sums. Question 2 is on the screen. You can copy it and solve that, please. Find the angle between A and B. So step 1, we'll be doing cross the dot product, which is at 5 and 4 and minus 2. Write them in one column. Dot, the second one is 2 minus 3 and a 4. That's it. We simply multiply and add. 5 times 2, 10. Minus 4 times 3, 12. Minus 2 4s 8. That's a 20, so it's minus 10. It's a negative number. Maybe the angle should be obtuse. We don't know yet. So we did that. We need modulus of A, modulus of B. So modulus is squaring them. Pythagoras, please. So that's a 5 square plus 4 square and plus minus 2 square under the root. That's a 25. And that's a 16 plus 4, 20. So we have root 45. We can leave it like that because we use the calculator in the end. Modulus of B, which is 2 minus 3, 4. So that's 2 square plus minus 3 square. You have to show the steps in the exam, please. Under the root, and that's a 4 plus 9 plus 16. 25 plus 4, 29. So those are the three values we need, 1, 2, 3, to find the angle between the two vectors. The formula to be used is now cos theta. So let's write that. Cos theta is equals to A dot B divided by modulus A multiplied by modulus of B. Simple substitution, then we can use the calculator. A dot B we already found, which is minus 10. Minus 10 on top. Calculators ready, please. This is root 45, root 29. So square root of 45 times 29. We can write them under 1. It doesn't matter. Shift cos. Find the angle, please. That's going to be a fraction. Top one is minus 10. And denominator is a square root of 45 multiplied by 29. That's what we have. Bracket closed. There you go, guys. The answer there should be 106 to three significant figures. That's obtuse angle, 106 degrees. The way to look at is, if the answer here, if you get as a negative, we are expecting an obtuse angle between the two vectors, okay? If it's a positive value, we have a lovely acute angle to do that. So that's how you find angle between two vectors, please. Next one. Examination questions they are, so listen very carefully. A equals to x minus 5z. B equals to 6, please. It is 6 and 2 and 1. Question 1, find x and z, those two numbers, given that A is at right angles to B. That's the information I have. So if the angle between them is 90, we know A dot B should be 0, isn't it? So let's say A dot B equals to 0. The dot product must be 0 because that's cos 90, which is 0. So dot product x minus 5 and z. Close it. The second one is 6 to 1. Write that, and equals to 0. We have an equation in x and z. So 6x minus 10 and plus z equals to 0. Take the z to the right hand, the minus 10 to right hand side. 6x plus z equals to 10. Now the question is, the x and z values, they can take any value because there are infinite number of lines like that, okay? So what we can say, let z equals to say 1, right? Or 0. So let's say z is equals to 1. Then we will have 6x plus z, say plus 1 is equals to 10. 6x is 9 and x equals to 9 over 3. 9 over 6. So the value of z is 1 and this is this. If you take that as a 0, well, it will be 10 over 6. If it's a 2, I mean, so you can take any value that you like as the values of z. But non-zero vectors, that's what you need to keep in mind when you solve these sums. So the angle the angle between the two vectors is 90. Okay, that's how you find the x and z values. There is no unique value for x and z. Remember that, please. Then question 4 is find the angle between this vector and the x-axis, right? 1, 0, 0 means we are actually talking about I plus 0j plus 0k means that's the unit vector on the x-axis, so, right? That's the right side of 0. So finding the angle between the two, or the vector making an angle with the x-axis. So we follow the same steps again. We find the dot product first. So we have a 9 minus 5 and a 3. And this is going to be 1, 0, 0. That's not bad. 9 times 1 is 9. That's all. These two will become 0. Then we look at the modulus of A, which is squaring them. So 81 plus 25 plus 9. That's what I have. 81 plus 9, 90. Add them. 115 under the root. And modulus of b, as we know, is just a 1, right? 1 square, and you find the square root, you still get 1. Then substitute them in the formula that we know. Cos theta equals to a dot b, which is a 9 there. So let's write 9 divided by modulus of a is here, modulus of b is there. So that's a square root of 115, that's all. And times 1 if you want to. Then use the calculators, please. Degrees, right? Shift, cos, fraction. We got 9 on top and divide by root 15, root 115. That's it. And bracket close. The answer comes down to be 32.9. So that's the acute angle, right? So theta equals to 32.9. So this vector is making an angle 32.9 with the x-axis, please. But that's 1, 0, 0 means, watch very carefully, if that's the x, y and z, this is what they meant, to the right side, because that's a plus 1. Go and check, that's a plus 1. If it's a minus 1, 0, 0, you should have gone that side, okay? So maybe that's the angle they are talking about, like. So that's, if they say find the angle with the y-axis, you take this as 0, 1, 0, right? Question 3. Well, once again, just find the angle between the two vectors, please. We need to practice lots of sums there. It's a 2, 3, 6. So let's find the dot product. A dot B is equal to 2 times minus 4 and plus 3 times 3, 9 plus 6, 8, 48. So 48 minus 8, which will be 40, 49 is the A dot B. Modulus of A. Let's do modulus of A, please. 2 square, 4, plus 3 square, 9, 6 square, 36. Looks like a good number. 13, so it's a 49. Under the root, we have a 7. Beautiful number there. And the modulus of B may not be that good looking. Modulus B is equals to minus 4 square, 16, plus 9 plus 64 under the root. Right, 16 plus 9, 25. That's 89, please. Right, under the root. There is no root for that. So those are the three numbers which will help us to find the angle now between those two vectors. Very important. Cos theta is equals to A dot B, which is 49. Right on top, and divide by modulus of A, which is 7, multiplied by root 89. You all know how to find theta, so I will leave that to you. All right. So that's how you got to find the angle between two vectors. The next question, I hope you will do that, right? The next one is here. It says, two vectors are given to me, A and B, and what they asked me to do was find a relationship between C and B. Look, we do not have any numbers there, right? That's 5 for C, 2 B and minus 3. If A is at right angles to B, if the angle between them is 90, they want us to find a relationship between B and C. So if the angle is 90, we know A dot B is 0. So just find A dot B. So 5 times 2, 10. Minus 4 times B, minus 4B. And minus C times 3, so minus 3C equals to 0. That's all. We get the relationship between B and C. So you can actually keep the B and C on the left hand side. 4B plus 3C is equals to 10. That's what you are supposed to get. So this is the relationship between C and B, if at all the angle between them is 90. The second part, based on the same question, is this. It might take a little long, so listen very carefully, please. If A is parallel to B, right, find the values of B and C. That's the question they asked me. If it's 90 degrees, well, we have just one equation, so we cannot find the unique values of C and B. The second one, the concept is, we did few questions, right? What we said was, if two vectors are non-intersecting, say if A is parallel to B, we said one is a multiple of the other. So that's what we need to do here. So one vector is a multiple of the other. So I'm going to write A is equals to lambda times B, where lambda is a scalar. So we substitute these vectors. A is a 5i minus 4j and plus ck. That was A, all right? That's A, and B is this. So copy B also with lambda, please. So that vector is a multiple of this. So inside the bracket, 2i plus bj minus 3k. That's all. Now, remove the brackets, take the terms to one side, make I, j, k subject. See what happens. I'm going to write 5i here. Open the bracket with lambda, 2 lambda I, take it to the left hand side, right? Minus 2 lambda I. I mean, there are many ways to do, right? Then copy the minus 4j, minus 4j, and multiply the j with lambda. So it's b lambda j, right? So that's a plus value. Take it to the left hand side, minus b lambda j. The last one is ck, so it's a plus ck, and open the bracket with k now. Minus 3 lambda k, take that to the left hand side. So we will have plus 3 lambda k is equals to 0. So the idea is to make I subjects. Just write I in one place and write that 5 minus 2 lambda. We are taking I as a common factor, and plus, just take plus, see what happens. J. So I have minus 4 inside and minus b. And the last one is k common, so it's a plus, bracket starts and a k. C is a c plus 3 lambda equals to 0. For this sum of all those three to be 0, right, that's 0, that's 0, that's 0. So equate them to 0, see what happens. I'm taking the first one so that I can find lambda, right? So minus 2 lambda plus 5 is equals to 0. Just equate that to 0, please. We have lambda is equals to 2.5 or 5 over 2. That's what we get. Now, equate that to right hand side. By the way, we have a lambda there, we forgot, right? So it's a minus 4 minus b lambda is equals to 0, and lambda value we can substitute and find b. right? Minus 4 minus 5b, right? Divided by 2 equals to 0. Transfer that there. So we have minus 4 equals to 5b divided by 2, which is minus 8 divided by 5. And the value of b should be, well, we can leave it like that, or minus 1.6. So that's it. Simply say one vector is a multiple of the other, say lambda or mu or any letter, open the bracket, take all the terms to left hand side, make I, j, k subject, equate each one to 0, we will get those values. We already have the value of lambda now, which is 5 over 2. Let's substitute there. C plus 3 lambda. So let me do that here. It's a C plus 3 lambda is 3 times 5, 15 divided by 2. That should be equal to 0. All the I, j and k, the brackets must be 0. So C is equals to minus 15 over 2 or minus 7.5. That's how you need to solve this kind of sums. The concept, when they say A is parallel to B, we can say one is a multiple of the other. So A is equal to lambda B. After that, you know what happened. We did few questions up to now based on the angle between two vectors and the concept of is parallel to, right? And also the angle between two vectors as 90. This is very interesting question we have here, which says two vectors are given to me and they asked us to find the value of cos A or B. That's all, right? They didn't ask us to find theta. By the way, A and B are position vectors. O is the center, right? So OA, OB are A and B respectively. Simply finding the angle between the two vectors, but there's more to go. So let's do it slowly, please. We need A dot B first. So let's write A dot B. Work it out before me and then you can check the answer. 7 times 2, 14 and minus 4 times 2, 8. Then minus, that's a 1 there, so minus 4. 14 minus 12 is a 2. So A dot B is 2. Let's find the modulus of A, right? Modulus of A is here. Modulus of A. Just to square those numbers, 49 plus 16 and 16 again under the root. So we have the value here as that's a 32, 9 to 11. So it's a 81. That's a nice number. So we got 9. Right? Modulus of A is 9. Then let's find modulus of B. Okay. That's 2 to 1. Modulus of B is equals to 2 square, 4 plus 2 square, 4 plus 1. Lovely question. Root 9, which is equal to 3. That's all. We have 3 numbers there, right? And we can use them now to find the cos A or B value. They didn't ask us to find the angle, please. They just said find cos A or B. So no need to use the calculator there. Cos AOB is equals to A dot B, which is 2 divided by modulus of A, 9, multiplied by modulus of B, 3. The answer is 2 out of 27, isn't it? That's the value of cos theta. Remember, call it theta, right? Cos theta. So that might carry 2 marks or 3. Then they said find the area of the triangle AOB. So the situation is you have the center point, let's say that's the X, Y and Z axis, right? That's OA, that's OB, for example, right? They wanted us to find the value of cos AOB. Then now they're asking find the area of the triangle. So we go back to C1, C2 or GCSE. We all know it's a half AB sine C, right? So 2 sides we know, that length we know, that length we know. We just need the sine theta value. Trigonometry, very handy, please. Sine square theta plus cos square theta is 1, right? If I need, I know